Assalamualaikum warahmatullahi wabarakatuh. We are in part 3 of IR spectroscopy. Now we continue with the classification of IR band. As we all know, the y-axis is a percent transmitted, and we have several diagnostic region. We have weak, medium, and strong, and also this one is called as broad. Okay, either broad, strong, sharp, weak, and medium. I want to show you my example of the fingerprint region, not fingerprint, functional region, functional group region. So we have a several diagnostic region. We have sharp, okay, sharp, weak, broad, and strong. So which one you think is the sharp peak? Okay, sharp peak should be the one that have a very obvious and very sharp sharp peak. Okay, so this one is considered as a sharp peak, and this one is considered as a weak peak. Okay, because when we compare between a sharp peak and weak peak, it obviously we can see that this peak is very sharp, and this one is slightly weak compared to this one. Okay, and which one is broad peak? Okay, which one is the broad? This one is sharp. Okay, and the one that is broad peak. Okay, I will draw you the other peak. Okay, one that is broad peak. Okay, so this one is a broad peak. Okay, we have broad and strong. Okay, this one is also called as strong. For weak peak here, and this one is sharp, this one is broad, and apa lagi? Broad, strong. Okay, strong. Also, this one also called as a strong. It narrow and strong. This one is broad and strong, very strong. Okay, kalau compare this graph with this region, okay, we can make a comparison. Graph below is very broad and strong bond compared to this one. It's also quite medium broad, but it is weak, not weak, medium, medium apa panggil medium region lah. Okay, compared to the graph below. Okay, now we proceed with our slide. Oh, sorry. Okay, for this explanation, we can the maximum percentage of transmitted is 100%. Okay, 100%. So let's say if you have the number of transmitted here is 80%. Okay, 80%. You can conclude that let me draw here 80. Okay, alah payahnya nak tulis 80. Sorry, I just use a painting. So if you have 80% of this compound right here at this peak, so it means that 20% of the energy was absorbed, and the remaining 80% was transmitted through the sample. Okay. So for the conclusion, we can observe from this functional group or the wave or the graph I draw, the shape of the signal, it can have a broad or sharp shape. So for broad shape, example of the functional group, we have OH, okay, hydroxyl or amine group, NH, because H bonding or hydrogen bonding in a molecular bond formed between molecules are OH, COH, okay, so it has a polar group. So polar group tends to produce more broader peak compared to other group. And also we have C double bond O. Okay, so C double bond O also very polar because of the presence of the O. So all this bond, it have a dipole interaction between C and O. Okay, it has a partially positive charge and negative charge. For the sharp peak, mostly sharp peak functional group are non-polar. It don't have dipole-dipole interaction and hydrogen bond. For example of sharp peak is carbon-carbon double bond and also carbon-carbon triple bond. This one is the details region in FTIR. You can see that this one is alkane CH. CH stretch has a wave number between 2400, and we have CH3 band at the fingerprint region, okay, which is less than 100 for 1400. We also have a CH2 right here. Okay, for alkene C double bond C, it has the wave number around 1600 to 1800. Okay, and the other is carbon-carbon triple bond, NH, OH, and so on. So you can roughly estimate what type of the functional group and what is the wave number of that functional group. Now we look at the alkene first. Okay, alkene we have CH stretch for the octane structure. This one is the octane structure. So what you need to do, you have to analyze the structure. You need to find C double bond, C single bond C. Okay, functional group di mana? And CH. We have CH dengan CC. So CH is the alkane stretching, which is lies right here 2971, and we have scissoring CH at 1470, and also CH right at the methyl rock. So macam ni lah cara kita nak tentukan dia punya functional group dia. Okay, very simple for the alkene structure. If the structure is simple, so it is quite easy for you. Now we look at the alkene. The stretching vibration of carbon-carbon double bond usually give rise to a moderate bond in the region 1680 to 1640. Okay, this structure it has carbon-carbon double bond. So kita tengoklah dekat mana CC double bond ni. CC double bond dia dekat 1600 lebih. So awak tengoklah kalau ada peak yang keluar dekat wave number ada peak 1644. Ataupun dalam region yang ni lah 1680, 1640. So dia adalah peak double bond. So di samping itu awak kena tengok juga peak lain. Peak yang muncul ni warna hitam ni kan. So awak determine lah number dia ni kalau dalam region CH awak letak lah. Dia adalah CH region macam tu. Make sure tak lari daripada structure yang awak cari. Jangan tiba-tiba awak nak labelkan NH pula kan. NH tak ada dalam structure sini. So just ignore the other functional group. You just focus on the functional group of that compound you want to determine. Now we look at the alkyne. Okay, alkyne are compound that have a carbon-carbon triple bond. Carbon-carbon triple bond stretch 2260 to 2100. Okay. So dia tengoklah kalau ada H kat belakang tu, so lain dia punya number dia. Okay. But don't get jangan susah hati, saya akan bagi table yang senang untuk awak refer. Okay. So dalam alkyne, you need to determine the carbon-carbon triple bond dekat wave number yang mana, and you need to determine the CC and also CH and also C triple yang belakang ni, CCH ni. Okay. Now we look at the alkyne. So as we can see that alcohol, which has a functional group OH, is stretched around 3,500 to 3,200. So we can see that it has a broad with rounded tip right here. Okay, broad peak with rounded tip. So secondary amine also has a broad peak with one sharp spike. Okay, kita tengok yang secondary amine pula. Carbonyl. Okay, tak apalah, tengok carbonyl dulu. Carbonyl has CO. CO sama lah, kalau you have a structure of carboxylic acid, you can determine the carbonyl group. Give rise to a strong absorption in the region 1820 to 1660. The peak is often the strongest in the spectrum. Okay. We have CO stretch ester. Okay. Untuk structure yang ni awak kena cari dia punya benzene ring dia, C double bond C double bond C lah, C double bond O. Okay. So macam tu lah, nanti saya bagi example. Don't worry. Alright, this one is carboxylic acid. Okay. Senang je. Ketone, aldehyde. So the carbonyl group of sample ketone, aldehyde and carboxylic acid, it will absorb around 1,700. So usually it is the strongest IR signal. And carbonic acid will have a OH bond. Aldehyde have a 2 CH signal around 2,700 and 2,900 and 2,600. Okay. Okay, now we look at the structure of both butyraldehyde. Okay, so kita ada CH. Awak kena cari mula-mula awak tengok dulu structure ni. You need to look at the structure. You need to know what is the structure of the compound you want to search for. So we have CH. Awak kena cari mana CH with number dia kat mana. Ada tak CH? Awak kena tengok balik table appendix. And then kalau dalam table tu dia bagi region sekian-sekian, awak cari ada tak region yang number warna hitam ni kan. So it has one CH here, right here. And then CC pula, mana CC dia, ada tak CC kan. And then cari C double bond O. Okay, C double bond O sangat obvious kat sini, nampak peak dia kan. Macam tu je, senang je. Okay, for this benzaldehyde, ada CH, okay. Ada C double bond O and also C double bond C. Ada C double bond C kat sini. Tapi tak tunjuk lah pula. Okay, for nitro group. Nitro stretching vibration is nitroalkene occur between 1550 and 1365 symmetrical. If the nitro group is attached to an aromatic ring, the NO stretching band shift down to slightly lower with number. Okay. The structure of nitromethane. So we have NO and also NO right here. For amine, NH stretch of amine are in the region 3,300 to 3,000. These bands are weaker and sharper than those of the alcohol. Okay. So amine ni dia ada dua hydrogen lah kalau NH2 kan. And it have a symmetrical stretching, and also it has a symmetric. Dia ada one primary and secondary and also tertiary amine. Because in the tertiary amine it has no band in this region, so we just focus on the primary and secondary amine. So for primary amine, it has two hydrogen, which is lies 3,300 to 3,200. For secondary amine, it lies between 3,300 to 3,310. So we also have the NH band CN. So dia punya number tak sama. Okay. How to analyze the IR spectra? I will explain in the next slide.